Hey, welcome to a new series of videos where I create an app from scratch. This is part 2. In this video, I will show you how I added 2 features to the Mindmap app. First, how to delete a node. Second, and the biggest, how to serialize the state of a map and save to disk. So let's take a look at a brief demo. I will create 2 maps and save each one. Notice you can give a name to the map now. The maps are saved locally on the device. Cool, let's jump to the code and find out how the node deletion is done. This is quite simple. Just as before, this would be a recursive call to search, but with an added task of deleting the node when found. So I created a new function just for deleting. I hooked this up to long press on the canvas. I admit that this user experience is not the best, but I will revisit how best to provide the create, rename, delete operations on the nodes. But for completion and simplicity, this is just fine. We are making progress. That's the most important thing. So here's the node class we encountered before. This is the data structure that underpins every mind map. Delete node function takes in 2 arguments, a starting node and a position to hit test for. Hit test is the name of the operation where we check if a user interface element was hit by a pointer interaction like tap. It starts with a simple sanity check where if the node is null, we return. Then we iterate over the children and check if the hit test satisfies, and note down the index of the node in children list if found. Then right after the iteration, we remove the node if it was found and return. If not found, we recurse on each child. One thing to note is that this deletes the node and the subtree it contains, which is what we want. What's not there yet is confirming the user decision to delete. We will get to that at a later date. Now let's take a look at the node serialization. This is a bit complex. I want to serialize the state of a node to JSON and back. So looking at the docs, there are a few options I could take. Which JSON serialization method is right for me? And we click on that. Manual serialization and automated serialization using code generation. So since our project is small, I will use manual serialization, serializing JSON manually using Dart convert. So this is what we need to do. There are 2 things that we need to do in our model class. This is what the docs say. And the reason for doing that is mentioned over here. Have a look in the docs. So basically what we want to do here is to create 2 functions or 2 methods in our model class. There's the model class in this example. The 2 functions that we need to provide are from JSON and to JSON. From JSON builds an object of the class from a JSON object. ToJSON function returns an object with whatever we want to serialize. Note that these 2 functions should match in terms of what fields we want to serialize and deserialize. Okay, so now let's jump to our code and see what we need to do to serialize. ToJSON function looks like this. We are serializing 2 fields, value and children. This is because the rest of the fields in the class are computed during rendering. Since children is a recursive definition, we need to iterate over the children and create JSON objects for each of them. Since we called toJSON on each child, this will serialize the whole tree. And now let's take a look at the deserialization. Setting value field is straightforward. Children field needs a little bit of explanation. First, we cast the JSON object as a list because that's what we expect it to be. So then we can map over each of the JSON object and call from JSON on each of them. But this again is a recursive call, so it builds the node tree correctly. Serialization is quite useful in multiple ways. Saving to disk or sending it over the network is the most obvious. But at a later time, we would want to support undo and redo. For that, we could easily save state in a doubly linked list and traverse to support undo redo. Now we have the basics to save a map, but we have a bit more metadata about a map, such as name, a file name, and optionally a screenshot. This would be the link to a screenshot PNG. So we define those in the Mindmap file class, as you can see right here. Just as before, we provide two functions to enable serialization and deserialization. Now, attaching the actual state of the mind map is quite easy. It's a matter of calling toJSON and from JSON, just like that. Let's take a look at how we use them. This is what the new user interface looks like. We have added an app bar on top, so we can provide things like a title, a back button, and a save button. When the save button is pressed, we call save map. Let's take a look at the code. So we are on the Mindmap page. That's a scaffold. This is the app bar, and we have added a save button in the actions. This is the title in the action. Let's take a look at the build save button, which is a flat button, and on pressed, that's where the action happens when we want to save. So we provide a simple save or cancel dialog when it is pressed if the title is not set, or something like let's go back over here. So for example, new mind map, and then I create those things, and then if I click on save, it will ask for a name. So we'll call it test map 2, save, and we get back. Right now you have to reload this manually, but at a later time we will fix that. When the save button is pressed, here we call the save map. Let's have a look at what it is doing. We show a little dialog so the user can set a title or name to the map, and then save map is called. Save map encodes the current mindmap file object and calls write file. Write file sets that file name and save the payload in the application's documents directory. This is a folder only the app has access to, and it is deleted when the app is deleted. So it is quite safe. Now let's take a look at how these files are loaded back. That is implemented in the welcome page. This page is what the users see when they open the app. It has a button to create a new mind map and a list of saved maps. By clicking on the create button, it calls mindmap page with the null object. So it will create a new Mindmap file object in the init state. Let's look at loading the files. That happens in the load mindmap files, and it is called from the init state. Here it gets the application documents directory and calls list function on it. And the output of that is a stream of file system entities. The listen callback is called for each of them when they are found. Reading from the disk is a time-consuming task compared to UI workflow. Load mindmap file opens a file with the path and read the contents to a string. This is passed on to JSON decode, which returns a JSON object. Then we call from JSON function to get a mindmap file object. This object is added to our mindmap files list inside a set state so that the app redraws and displays the items correctly. Now, a little demo of tapping on these items. They display the correct map. This is because we built the list tiles using the list of mindmap files, and each of the list tile is associated with the backing data structure. So when onCall is called, it binds the right item to the mindmap page constructor. In the mindmap page, we build the mindmap widget in the tree structure embedded. In the last week's video, we looked at how you can draw a tree given its root node. So here we are, just making use of what we already have and building a opponent. So that's it for this video. It's a bit too long already. Next week, I hope to add 2 more features, zoom and pan. Join me on the Twitch live stream where I do a live coding session. It's at 3 p.m. GMT. Check the description for the details. As usual, if you like what I create, like, share and subscribe to channel to support it. Until next time.